some way, right? So we're going to start here by defining sine, cosine, and tangent, which, like I said, you already know and you've already used, and you used them this morning to find the missing parts of your triangles. But then we're also going to investigate cosecant, secant, and cotangent, which should sound familiar, right? But maybe you don't know as much about because you haven't done it as much. But it all kind of stems from the same thing. So I want you guys to tell me, so when you do sine of an angle in a right triangle, what are you thinking? What is it equal to as far as what you're using in the triangle then? Yeah. Opposite over the hypotenuse. Yep. And I just do little abbreviations here. Hope that's okay. Op over hype. Okay. Cosine. What did you guys use? Those groups that had to use a cosine, it was what over what? The adjacent over hypotenuse. Yep. And then I think there were at least a couple groups that had to do a tangent. What did we use for a tangent? Opposite over adjacent. Yeah. Okay, so those are your regular three trig functions. And then we have these other three that are called the reciprocal trig functions. What's a reciprocal? Yeah. Yeah, so they take each one of these little fractions and they flip them, okay? So we have cosecant, which the abbreviation is CSC. And cosecant is equivalent to 1 over sine. So I'm going to go ahead and write that in here too. It is the reciprocal of sine, so 1 divided by sine, but as far as the opposite hypotenuse stuff is concerned, it just flips that fraction then, so it's hypotenuse over opposite. Okay, and then we've got two more, same kind of thing. Secant is the reciprocal of cosine, which then would be the hypotenuse divided by the adjacent. And we've got our cotangent, which is 1 over tangent, which would make it adjacent over opposite. So if you're given a right triangle that has some things labeled on it, some measurements on there, you might be asked to calculate any one of these 6, or maybe all 6. Okay, so let's practice that for a minute here, just real quick, and then we'll move on because this is, I think, kind of easy stuff for you guys. So here's our right triangle. Let's say our angle is down here. Maybe this is 3, this is 4, and this is 5. So, real quick, I would like you to tell me what is the sine, cosine, tangent, cosecant, secant, and cotangent of theta. Write down all 6 of them. Alright, then in a minute I'm just going to randomly call on some people and we're going to just fire them off real fast. So, who are we missing today? There's one person gone. All right. So, you guys ready? Okay. So, cosine. Michael. Good. Sine, Clint. 4/5. Good. Carson, tangent. 4/3. All right. Heidi, secant. 5/3. Good. Garrett, cosecant. 5/4. And she's not here. Emma, cotangent. 3/4. Okay. Now, the only other little wrinkle that you might see with this type of a problem is if they give you a right triangle and there's one side missing. So what do you do if there's one side missing to find the missing side? Yeah. Right. So there might be a step of do the Pythagorean theorem, find the missing side. Okay, then you can go do all of this. Okay. So I don't want to belabor that too much, so we're going to just move on here. Next thing I want to look at are a couple of special right triangles that you've seen before that are going to help us in the future here. And these are going to be, there's some angles in these right triangles that you are going to have to be able to do cosine, sine, tangent, secant, cosecant, cotangent, just in your head, not with your calculator. So the first one we'll look at is the 45-45-90 triangle. Try to make that look 45. Okay, so here's your right angle. Here's 45, 45. Okay, and there's a relationship with the sides on this one. Let's see if you guys remember what that is. Anyone tell us? Yeah? Both the legs are the same. Okay, and then how is the hypotenuse related to the legs? Okay, so we could go x, x, whatever these are, and then x times the square root of 2. Okay, but I'm going to break that down into, okay, well, let's just assume these were both 1, and then this would be square root of 2. So they hold that kind of ratio, and you could multiply them all by whatever, right? So instead of 1, 1 square root of 2, it might be 2, 2, 2 times the square root of 2, or 3, 3, 3 times the square root of 2. It always holds that same ratio with those three sides. Okay? So, if that's how that triangle looks, then we should be able to do this. Let's start with just cosine, sine, and tangent. So, if cosine, like we said, is adjacent over hypotenuse, what is the cosine of 45? 1 over square root 2. And typically, we see these things rationalized. So if I multiplied by square root 2 over square root 2, what would that get me for this one then? It would be square root 2 over 2, because the square root of 2 times the square root of 2 is just 2, right? So there's your cosine. What about the sine of 45? Same thing, right? 1 over root 2, which if you rationalize it is square root 2 over 2. Okay, so that's one that you should know. And then what about the tangent of 45? It's just 1, right? 1 divided by 1. It's 1. Okay. And then if I wanted to find the cosecant, secant, or cotangent of any of these, what do? Just flip them over, right? Okay. So, let's see. The secant of 45 would be actually just the square root of 2, right? Think about flipping this fraction first. It would be easier. So that's just the square root of 2. The cosecant of 45, same thing, square root of 2. And then what about the cotangent? If the tangent's equal to 1, what's the cotangent going to be? Also 1. Okay. Now really, the only ones that I would ask you to memorize would be these three: cosine, sine, and tangent. Because if you know those, you can get these, right? Just flip the fraction and simplify it, whatever, you got it, okay? So when we start talking memorization and all that kind of stuff, just focus on the cosine, sine, and tangent, okay? We'll worry about these after that, because then you can just flip them. Okay, so radians, you're going to see them both ways. So 45 degrees, I might not ask it as a 45-degree angle. I might ask it in radians. So what is 45 degrees in radians? Yeah, question?
Yeah, why do you go to the square root of 2?
Because that's just how it's typically written. Because square roots and denominators, you don't usually see them that way. So it gets written like this instead. It's just, the only reason that you rationalize something like that and change it into that is because if you were to go and use that number later in a calculation, it's easier to have a square root on the top than it is the bottom. Technically, it doesn't matter, though. You can still use this 1 over the square root of 2, and it works just fine. And I'll never mark that wrong. If you want to use it that way, it's fine. But just when we move forward and we start doing more stuff with this, you're going to probably want to use the square root of 2 over 2 in your calculations moving forward. So, okay, so back to my other question, though. So let's say I have a triangle with radians in it instead of degrees. If I'm using a 45-degree angle, what would that be in radians then? Yeah. Pi over 4, right. If we do our little conversion like we talked about in the last section, that would be a pi over 4 angle. So if I ask for the cosine, sine, or tangent of pi over 4, you should be able to do that too then, right? It's all the same thing. Okay. So that's the 45, 45, 90 triangle and some trig from that one. We also have this guy, the 30, 60, 90 triangle. Okay, so does anybody remember what the relationship with the sides on this one is? This one's a little more tricky. Heidi, do you get it? No?
The side across from the 60 equals x, right?
Mm-hmm. So if this is x down here, what are the other two then?
2x and x squared 3.
Okay, and which one's which?
X squared 3 is the hypotenuse.
Oh, you're close. This is actually the 2x. So what I'm going to do is, let's say this is 1. Okay? So the way I always remember it is, whatever the short leg is, that's 1, or x. And then the hypotenuse is always the twice as long one. So this would be, in this case, 2. And then the other leg is the square root of 3. Okay? In 30, 60, 90s, it's square root 3 and 1 are the legs, and then the hypotenuse is 2. So using this triangle, we're going to come up with some more trig that you guys should have memorized here by the time we're done. So cosine, sine, and tangent of 30, as well as cosine, sine, and tangent of 60. Okay, so looking at that triangle, what is the cosine of 30? One half. Yeah, good. All right, what's the sine of 30? Mm-hmm. Square root 3 over 2. Are you okay, Hasley? Yeah. Sorry. Yeah. Okay, so try again. Yeah, sorry about that. Okay, yeah. So cosine of 30 would be square root 3 over 2. That makes a lot more sense. And so the sine of 30 should be 1/2. All right, and then what's the tangent of 30? 3 over 3. Good. Once you rationalize it, right? It would be 1 over the square root of 3. And then if you rationalize, yep, it's square root 3 over 3. Bless you. Okay, cosine, sine, and tangent of 60. What's the cosine of 60? 1/2. What's the sine of 60? And the tangent of 60? Square root of 3. Notice anything about those? Is there a relationship between the 30s and the 60s? We're not going to do those just yet, but just what you see here. What's the relationship between them? Yeah, cosine and sine switch, right? So the cosine of 30 and the sine of 60 are the same thing, and the sine of 30 and the cosine of 60 are the same thing. Okay? And then what about the tangents of 30 and 60? What's the relationship between those two? Well, you get rid of the denominator, but technically what's happening is one is the reciprocal of the other. Think about that, right? If you did the tangent of 30, you were doing 1 over the square root of 3, right? And when you did the tangent of 60, you were doing square root 3 over 1. They're both two fractions. One's just been flipped for the other, right? So there's that relationship that's happening there too. And those are just some things that have helped people in the past when they're trying to memorize these and move forward with it. So, all right, and again, secant, cosecant, cotangent. I might ask you to do those as well, and you can do those because it would be just one of these flipped, right? You can just take whichever one you need and then flip it. And also, we need to keep track of, if I do this in radians. So 30 degrees in radians, and I'll just tell these to you so we don't have to spend time with it. But 30 degrees is pi over 6, and 60 degrees is pi over 3. So what I'm going to do is, I'm going to put up some sine, cosine, tangent, secant, cosecant, cotangent problems of some random angles. Well, not exactly random. It's going to be either 45, 30, or 60, or pi over 4, pi over 6, or pi over 3. And see if you can use what we have written down right here to evaluate these without using a calculator. Okay? And then we'll call on some friends to answer for us here. So let's do cosine pi over 3. Sine 45. Cosecant of 60. Cotangent of pi over 4. Secant of pi over 6. Tangent 30. Cosecant 45, and maybe secant pi over 3. Okay. So, see if you can do it. What each one of those is equal to. What's the fraction? Based on the results of our little triangle investigation up here, can you calculate what each of those would need to be then? All right, do you guys need more time? Yes? Not yet. There's one more thing I want to show you. Okay. I got a little impatient, so I'm going to unfreeze this and just show you all the answers, and you can check them. You're welcome. Now, the cosecant of 60 and the secant of pi over 6, if you want to just leave those as 2 over the square root of 3, not a problem. But I did technically rationalize those then in 2 square root 3 over 3. So just so you guys are aware, I don't know if you've noticed my pre-calc classes in the past where there's been like a lineup at the door.
Yeah.
You ever seen that before? I got these flashcards that I make people do stuff with. It's this.
Oh, this is it?
This is it's this, and then as we move on, I'm gonna add more cards in the deck. But basically, to get in the room starting Monday, you're gonna have to answer one of these ones you have to do in your head on a flashcard. Okay. Now I'm gonna not do the secant, cosecant, cotangent to start with. I'm just gonna do sine, cosine, and tangent, just of 30, 60, or 45, or in radians. So you got to maybe this weekend start kind of checking it out if you need some help with that. But yeah, that's going to be your ticket in the door starting Monday. Is can you get through the flashcard? Yeah. Cosine of pi over 3. Pi over 3 is 60 degrees. So cosine of pi over 3 is the same thing as cosine of 60. And cosine of 60 is 1/2.
I don't know why.
Yeah, I don't know. You did sounds like you did a secant.
Yeah.
Yeah. Any other questions about any of those before we move on? We're good? Okay. Very quickly, let's talk a little calculator stuff. You used yours this morning, so I know you guys know how to do this in general, but I want to see if we can do some secants, cosecants, cotangents on your calculator. So let's say I presented you with a problem where you needed to find the cosecant of like 48 degrees. How would we go about doing that on a calculator, because there is no cosecant button on your calculator? Any ideas? Yep. Exactly. Because it's the reciprocal of sine, you can do 1 over the sine of 48, and that should work for you. Again, make sure your calculator is in degrees here when you're doing this. All right, and so the cosecant of 48 degrees should be about 1 point. Let's take it out 3 decimal places for all these guys. So 346. Yeah, 1.346. Okay, how about cotangent of pi over 12? You would, yeah. So be careful. You're going to be flipping back and forth a lot with this stuff. So cotangent of pi over 12. Calculator needs to be in radians first of all, but then how do I go at this one? 1 over the tangent of pi over 12, which should be, back to radians, 1 over tangent pi over 12. So it should be about 3.732, that sort of thing. Okay. I just wanted to really quickly show you a couple of these just so that you guys know. For the ones that you don't have to have memorized, there is a section of calculator ones where you have to be able to use your calculator to get at some of these secants, cosecants, and cotangents. So just do the reciprocal, type it in that way, make sure you're in the right mode. It doesn't need to be difficult, but just be careful of that, okay? All right, and then the last thing is going to be inverse trig, which you also did when you were solving your triangles, right? If you had to find an angle, right, you had to do the inverse cosine or inverse sine or inverse tangent, that sort of thing. Well, there's going to be some questions on here where it's going to be ones you have to do by hand, not with your calculator, and it's going to be related to those triangles we just talked about too. So if I had something like cotangent of theta equals 1 over the square root of 3, let's say. And I need to figure out what is the angle that makes this true. Okay, so if I was going to try and do it like directly, it'd be, okay, so it'd be the inverse cotangent of 1 over square root 3. Can't really do that, right? So how could I manipulate this equation to kind of get things going here? Yep. Okay. So if the cotangent of theta equals 1 over root 3, what's the tangent then? Just square root 3, right? Okay. And so this is the one where we kind of need to know what it is. So what angle was the one that when we took the tangent of it, we got the square root of 3? 60, right? So our theta is 60 degrees. Or if I wanted it in radians, what would it be? Pi over 3. Okay. So you're going to be asked to do some of that kind of stuff too. There is some inverse trig you do on your calculator, just like you did solving your triangles. Other ones, though, where you might have to do it by hand, but just turn it back into a cosine, sine, or tangent to begin with, and then try to think about what's the angle that equaled this thing that I have. You got to kind of think it backwards. But okay, I think we're good. That's all I wanted to show you guys, so we can get to some homework now with the time we got left here.